Another short video, this one about multiplying rational numbers. In many ways, multiplying rational numbers is the most straightforward of all the arithmetic operations. Much easier than adding and subtracting, and just slightly easier than dividing. So let's take a look at an example. 4.5 times 2 2/3. Now here, you definitely do not want to deal directly with the mixed numbers. The first task here should be to convert the mixed numbers into common fractions. So let's do that for 4.5. You can do that off to the side, or by now hopefully you're getting practiced enough. You can just simply take the numeral part, the integer part 4, multiply it by the denominator 2, that's 8, and then add that numerator 1, so you get 9. So we have 9 over 2 times, when we do the same for 2 2/3, we get 8 over 3. So multiplying rational numbers is as simple as multiplying the two numerators, in this case 9 and 8, to give us 72, and multiplying the two denominators, 2 and 3, to give us 6. So let's just write that number off to the side here. 9 times 8 would be 72, and 2 times 3 would be 6. So that would certainly be fine. We'd want to reduce that, and you can probably see already 72 over 6 reduces to 12. But there's, in general, a much easier way to deal with this, to keep the numbers smaller and more manageable and not have to worry about reducing these big numerator and denominators later on. And that is to simply look for common factors in the numerator and the denominator. So 9 over 2 is fully reduced, and 8 over 3 is also fully reduced. But when you are multiplying, you're essentially creating one big fraction. And so you should just write it as one big fraction. So what do we have in the denominator? We have a 2 and we have a 3. And let's see what factors we have that can cancel with 2 and 3 in the numerator. So 9 clearly has a factor of 3, so let's write it as 3 times 3. And the 8 clearly has a factor of 2, so let's write it as 2 times 4. So now we can see there's common factors in the numerator and the denominator, and we can simply get rid of them because 3 over 3 is just 1. And the same with 2 over 2. And so what are we left with? We're left with just 3 times 4, which is 12, which is exactly what we would have expected had we just multiplied the numerator and multiplied the denominator and then worried about reducing it. Now, under no circumstances should you try to just directly multiply the mixed numbers by somehow dealing with the integer parts and the fraction parts. You're really going to end up with a much more complicated problem. You cannot simply just say, I'll deal with the 4 times the 2, that gives me 8, that's easy to do, and then I'll worry about the half times the 2/3, that would give me a third, and so I'd have 8 and a third. That's clearly not the right answer. So what's going on here? Why does that not work? Well, the easiest way to think about this is if you think about a rectangle that has dimensions 4.5 and 2 2/3. So if we have a rectangle, and nothing here is going to be drawn to scale, but let's say that the width here is 4.5. So we have a part that's a width of 4 and a part that's a width of a half. And then let's say that the height of this rectangle is 2 2/3. So we have a part that's 2 and a part that's 2/3. So you can see there are really 4 separate parts of this rectangle that need to be calculated. So you've actually created 4 multiplication problems. So the 2 times the 4 is easy, that's straightforward. The 2 times the half is just 1. The 4 times the 2/3 gives us 8/3. And the half times the 2/3 gives us 1/3. If we add all that up, you can see that on the top you have 8 plus 1 is 9. 8/3 plus 1/3 is 9/3, which is 3. 9 plus 3 is 12. So you get the same answer, but a lot more work and a lot more places where you can make mistakes. So in general, do not deal directly with the mixed numbers or mixed fractions. Let's take a look at another example. If we have 3 fractions, let's say we have minus 3/10, and we're multiplying that by 15 over 7, and multiplying that by minus 21 over 9. So there is actually a reduction that can take place with the 21 over 9. And if you can reduce right away, go ahead and reduce. But let's say you didn't spot that. One thing that I should have mentioned in the previous example is we shouldn't forget about estimating. All right, the previous example had 4.5 times 2 2/3. That's roughly about 4 times 3. So we're expecting something about 12. So when we actually get 12, we shouldn't be surprised. What do we get when we estimate this one? It's a little bit tougher. The 15 over 7 in the middle is around 2, a little bit bigger. The minus 21 over 9 is around 2, again, a little bit bigger. And the first fraction is about a third, negative a third. The first thing you really should pay attention to is the negative signs. We have a negative times a positive times a negative. So the result is going to be positive. So if you have a third times 2 times 2, you basically have a third of 4. It's going to be a little bigger than 1, probably not as big as 2. So we're expecting something between 1 and 2. Let's see what we get. Well, again, you're multiplying fractions. So the result is really just one big fraction. Let's try and find places where we can cancel. So we have that 3 on the top. I'm not going to bother writing any negatives because I know the final result is positive. The 15 is certainly going to be able to cancel with the 10. The common factor there is 5. So I need to write 15 as 5 times 3. And I need to write the 10 on the bottom as 5 times 2. I have a 7 still on the bottom that I haven't recorded. The 21 obviously is going to have a common factor with the 7, so I need to write that as 7 times 3. And the 9, I need to break that up into 3 times 3. All right, so now we're just simply looking for common factors in the numerator and the denominator. Let's start with the 5s. So there's a 5 that I can get rid of in the numerator and the denominator. There is certainly a 7 I can get rid of. And there's a couple of 3s that disappear. There's 1 3 there and 1 3 there, and they disappear with that. So what am I left with? The only thing I've got left on the top is a 3, and the only thing I have left on the bottom is a 2. And remember, our estimate, we thought it was going to be somewhere between 1 and 2. This is exactly halfway between 1 and 2. It's 3 over 2, which is 1.5. Now, I'm perfectly happy with you leaving the answers to these problems in common fraction form. So 3 over 2 is fine if you really want to, or if the question specifies, you can put it back into mixed numeral form, which would be 1.5. But I'm perfectly happy with 3 over 2.